Okay, so I want to look at this last example, and I realized I had a typo in it, so I had to cut the last clip. So we're starting with example 11, and if you could do me a favor, though, and fix your workbook, so that's the function you have, 4x squared plus 3x plus 1. And so what I really like about this problem, though, is you're approaching infinity, you might initially think, well, okay, you know, like this is like a 2x, so that's infinity, and like the square root of 4x squared, if I look at that as my lead coefficient, that could be the 2x. So is this thing really behaving like 2x minus 2x if I look just at those two terms, and therefore is this limit actually equal to 0? This idea of infinity minus infinity, does it in fact equal 0? And the thing is like, no, most likely it does not. Because infinity is not a number. They're not constants that when I have two of them I can subtract like if they were values. And that's kind of where this misconception of infinity minus infinity equaling 0 comes from. Infinity describes a rate of increase. A function is increasing without bound. And so this infinity minus infinity, you're really basically comparing two rates. And the thing is that you can't really tell who's getting faster when you're subtracting them. And so we need to reanalyze this problem in a way that we can compare rates, like infinity over infinity, who's getting faster, numerator or denominator. And so infinity over infinity is not equal to 0, and in fact it's one of our indeterminate forms of a number. Another number that we studied a lot this year so far is 0 over 0, another indeterminate form of a number. And in fact, in calculus, we're going to study quite a few different indeterminate forms of numbers. One of my favorite being 1 to the infinite power. That's crazy, right? 1 times itself an infinite number of times you would think is 1, and it's not. And the crazy thing is that it also has a basis in exponential growth and exponential decay, which is pretty cool. But anyway, enough of that. Let's look at this problem. And again, fixed it so it's a 3x plus 1. That was just a typo on my part. Okay. So what are we going to do? Well, we need to get a ratio. So we're going to create a ratio. And I know we did this last year in Honors Pre-Calc. We're going to multiply by the conjugate. So it's going to be 2x minus the quantity of 4x squared plus 3x plus 1. Remember, that's over 1. And we're going to multiply by its conjugate. So I guess we'll use red here. 2x plus the square root of 4x squared plus 3x plus 1 over itself. So I guess I can just visually see the conjugate here, this fancy one that I'm creating. Okay, excellent. Now, when we distribute this, so the 2x times 2x will give 4x squared minus, well, yeah, the outer and the inners cancel, minus, and then the square root squared will just give us 4x squared plus 3x plus 1. Okay, all divided by this denominator, 2x plus the square root of 4x squared plus 3x plus 1. Now remember, we're analyzing the limit as x approaches infinity. So now I can compare who's getting bigger more quickly, the top or the bottom. Or if it's a consistent rate, look at their coefficients. And so I notice that the 4x squared is going to cancel with this 4x squared, and I'm going to subtract 3x and a 1. So this is negative 3x minus 1. And then the denominator stays the same, 2x plus the square root of 4x squared plus 3x plus 1. But I'm going to notice that the behavior as I approach infinity, really, the 4x squared under the influence of the square root has the same degree as this 2x. So this is going to behave, the top's going to behave like a negative 3x. The bottom's going to behave like a 2x plus this as a square root. I can kind of ignore those negligible terms. That is a square root. As you're approaching infinity, I don't need to worry about plus or minus. It's going to be positive 2x. That's what this piece behaves like. And that's what, a negative 3 to 4 ratio. So this limit value is equal to negative 3/4. And so, like, out of context, if all I saw was this, I would think, okay, yeah, great. It's just like any other example we just did. But remember, where did this come from? This is an equivalent statement to this. And so all of a sudden, an infinitely large something minus an infinitely large something is equal to negative 3/4, which means that this piece of the function is somehow bigger than this piece. So this infinity is larger than that infinity, or at least in terms of how fast it's getting to that exponentially, or growth without bound. So side by side, we can't compare who gets bigger faster. But numerator, denominator, we can see that ratio because it'll start to approach a horizontal asymptote if we relate it back to the very beginning of the lesson. So kind of a cool concept. Every once in a while those questions come up where you're analyzing infinity minus infinity.